we are going to derive Maxwell equation in electric field. So we know that the potential difference between 2 points as the difference between the absolute potential between the 2 points. So what is absolute potential? The work done to bring a unit positive charge in the presence of electric field from infinite to that point is known as absolute potential. So for example, if you are writing the potential difference VAB, as I already told this in the previous videos, what is potential difference, what is potential. So VAB is the potential difference between A and B. So VAB equal to absolute potential in A minus absolute potential in B, and VBA equal to potential in B minus potential in A. So we can say that VAB equal to negative of BBA. So potential difference in AB is equal to negative of potential difference between B and A. Okay, this is similar. So by combining this we can get VAB plus BBA equal to 0. That means that this is A, this is B. So the potential difference between A and B is 0. So B, from B to A, the potential difference is also 0. So the sum of this potential difference between A and B in path this 1 and path this 2, okay, is equal to 0. So this is the potential difference is nothing but it is closed integration of electric field dot of dl vector. So AB plus BA equal to 0. So closed integration E dot dl means the work done to move a unit positive charge across a closed loop is also equal to VBA plus B, means the work done to move a unit positive charge in a closed loop is equal to the total potential difference across the path. Okay, but it is a closed path, as we saw the VAB plus VBA. So we are moving from A to B by path 1. So VAB equal to VA minus VB. So again we are coming back to A. So it is VBA. So VB minus VA. So summation of this, as I told, it is VAB is equal to negative of VBA. Okay, so VAB plus VBA equal to 0. So the closed integration E dot dl is equal to 0. So now this is the main thing, that the closed integration of any under electric field in any path is equal to 0. Okay, that means the electric field is conservative. So the work done in moving a unit positive charge or any charge in a conservative electric field is by an external force is always equal to 0. So now according to Stokes law, that I can write that surface integration of del is a gradient cross E, for any vector, for example A is dot ds equal to closed integration A dot dl. Okay, so where A is a vector, so cross product of any vector along in a closed surface is equal to line integral or the closed integral of that vector in a closed path. So we can say del cross E dot ds equal to closed integration E dot dl. So as we know, closed integration of E dot dl equal to 0. So from here we got del cross E dot ds equal to 0. So ds cannot be 0, okay, because the surface is finite. So that's why the only possibility is that the cross product of E vector with the gradient is equal to 0. So del cross E equal to 0. So that means this is our Maxwell equation. So the Maxwell equation tells that the cross product of the gradient with the electric field is equal to 0. That means, as we know, that the cross product, or we can say this is a curl. So curl of any electric field is equal to 0. That means the any vector whose curl is 0 it is an irrotational field. Irrotational field means that it will the work done by the electric field in a closed path, or the work done by that field in a closed path is equal to 0. So the curl of the electric field is equal to 0. So that means that this electric field is a irrotational field. So the work done by the electric field or against the electric field in a closed path is equal to 0. So again we can write the electric field is a gradient of V, negative gradient of the potential. So E equal to electric field we can write equal to minus del V. Now we can put in the equation del cross equal to 0. So we can get del cross minus del V equal to 0 from here. So we can relate with the help of the potential, with the electric field, all those things. Okay, so thank you for today's class. So I hope you enjoy, you understand what is the cross or the curl of any electric field, any conservative field, any field is equal to 0. That means that field is irrotational and it is conservative. So in any electric field except for the electromagnetic induction field, okay, so that the curl of the field, electric field, is equal to 0. That means it is a conservational field or a irrotational field. That means the work done by the electric field on a unit positive charge or any charge in a closed path is equal to 0, or work done against by the electric field by the external force to move a charge in a closed path is equal to 0. So thank you for today's class. I hope you will enjoy the next session. So sorry for the late video because I am busy in some other work. Okay, so thank you.